Recovery techniques in distributed databases. So here we're going to see all the techniques we need when the computer in distributed database crashes. Firstly, we are going to see the introduction, then recovery techniques, and a short summary. Talking about the distributed databases, we need to know that distributed databases is nothing but storing data on multiple computers. Now there are two methods while distributing databases over a network or a cluster. First one is replication and second one is duplication. Recovery protocols bring failed nodes back online. So why do we use a recovery protocol? In order to recover the things what we lost, the data we lost, and the failed nodes are back brought back online with the help of recovery protocols. Next is effectiveness of recovery protocol affects availability of the database. If the protocol is very strong, then the data will be available soon. If the protocol is very weak, then there may be a chance that the data may not recover forever. Now here are some recovery methods. First one is salvation program, second is incremental dumping, and third is audit trail, and there are many more. So first we are going to talk about salvation program. It is nothing but a post crash process that tries to restore the database to a valid state. So this method is applied when a crash has occurred. So this is the post crash process, and no recovery data is used here. Second is incremental dumping. Here the recovery is done on the incremental basis. Copies updated files to archival storage. Updated files are copied to the archival storage, performed either after TX completion or regular intervals. Audit trail. It keeps the track of a sequence of actions useful for database restoration to pre-crash state. Now, differential files. The separate file records updates requested for records in a main file. Differential file is nothing but it is a separate file records. They are requested and they are kept in main file. Backup or current version. Current version of database is stored in currently existing files with the present values. What may be the values? Multiple copies. Multiple identical copies of the database files are maintained, and these multiple copies are replicated on the different nodes. And if at one node the data is lost, we can recover the data from other nodes. So in this way, multiple copies are very useful. Then next is careful replacement. Update performed on a copy. Original is deleted upon commit. Original copy available after a crash during update. So basically what we do is we get a copy of the original document or original file, and then the original is deleted upon commit, and all the changes are performed on original copy, and the original copy is available after a crash during update. If we are updating a file and there occurs a crash, so original copy is available. Now dealing with recovery. While dealing with recovery, the following points are to be considered. Lower time to recover we need. These are the basic things that should we say characteristics or features. This features should be met. First one is lower time to recover. Low time should be required to recover the things. Reduce amount of recovery data to be transferred from active nodes. Log based and version based recovery support should be there, and support for amnesia phenomena. Now we are going to study about HARBOR, Harbor. This is a recovery technique for updatable warehouse-like systems. We know that warehouse is a place where large amount of data, structured, unstructured, everything is kept for a long period of time. So it is basically technique for updatable warehouse. Now queries active remote nodes. This queries actives the nodes which are situated far away from the main cluster. Timestamps determine which tuples to copy or update. So in this way, timestamps are very useful. It allows the non-DBA transaction while recovery and lower runtime overhead. Performance comparable to arrays. It's better. Does not require stable lock. It exploits the replication to support recovery, exploits historical queries, supports recovery in warehouse-like systems that require fine granularity, insertions and updates, uses versioning and time travel. Replication is not to be physically identical but must logically represent the same data. Logical representation matters. Provides K-safety, that is tolerates K-simultaneous site failures. The three-stage algorithm is: first, restore to the last checkpoint; second, update with historical queries; and third, update to the current time. So the summary is that while during crash recovery, no stable log is required. Non-DBA transactions are allowed during recovery. It exploits the historical histories to avoid read logs. No recovery log, then no force writes during commit processing. Performs better than Aries for insert and update intensive workload. Thank you.